Hello and welcome to another stream. It's been a while since I last did this. Let's see how it goes. So today I want to take a closer look at contract testing. And for this I already built a little POC. And my plan for today is to further improve the POC and make it more like something I could use in a real-world scenario. So the POC already proved that the general idea works, but now I want to see what it's missing to make this a solution that works for a real-world scenario as well. So this is going to be a kind of relaxed stream. I don't know how much I will be talking, maybe at least to answer questions in the chat, and at some points I might talk aloud about the thoughts I have. But first, let's start with taking a closer look what contract testing actually is. So there is already a tool for contract testing that I tried out, and I had some problems with it, and that's why I thought about building my own solution, obviously. And that's what the POC is about. But the solution that already exists is called Pact. And here we see the concept visualized. So the concept of contract testing is that we have a consumer application and a provider. So the consumer depends on some stuff that is provided by the provider, and then we have a contract that makes sure that whatever the consumer is expecting from the provider is delivered as it expects it to be delivered. And the goal is that we can test consumer and provider independently. So we want to make sure that we can run all our tests that we need to be confident that our consumer works, for example, without querying the provider. And also we want to run all the tests that we need to be confident that the provider works as expected without caring about all the consumers. So ideally the provider doesn't know about the consumers at all. Yeah, so there's a question in the chat. I plan to release the video on YouTube, I think. And it will be, as soon as the stream is over, I think it will be available on Twitch as well. But on Twitch it will be deleted automatically at some point, and I think I will upload it to YouTube as well. Yeah, so this is a very high-level overview about how this contract testing thing works. But let's go in a little bit of detail what I have in mind for my example. So now imagine we have a couple of applications. So the first one is a shopping list app, for example. Then we have an e-com app, so some online shop or something like this, something like that. And let's zoom in a little bit. And maybe we have some, let's call it shipping app that's responsible for handling shipping of physical products to people who bought our products. And then we might have a service, or we probably have multiple services, but to keep it simple, we have a single service like a product service, and all of those applications are communicating with this product service. So they get data from the product service. And now imagine that we have multiple teams working on this stuff. So here we have team A, and then we have team B, and team C. Those are all teams working on their products, like on different applications. And then we might also have a separate team that this was responsible for this service. And maybe those teams are responsible for multiple applications or only a single application, and maybe this team is also responsible for a couple of other microservices. Doesn't really matter. The important thing here is that we have different applications, we have multiple applications, and we have a service which all are maintained by separate teams. So whenever Team D makes a change to their product service, they somehow have to make sure that they don't break any of the applications. Because if they change the data structure of an endpoint, for example, you have to keep in mind that other applications are dependent on the data structure, and either they have to talk to the teams that they have to change something as well, or they need to do the change in a backwards compatible manner, for example. But no matter what, so if they change the data structure on purpose, then it's obvious that they have to do something. But sometimes, stuff happens and they change something that they didn't intend to change, but that breaks something in the applications. But how can they find out? Oftentimes we find out in production, and obviously that's not the best time to find out. We want to find out earlier. And how can we find out? So one way is manual testing. So Team D could have their own tester, for example, who launches all the applitions that depend on their product service, and then does manual testing to make sure nothing breaks. But as you can imagine, first of all, that doesn't scale, because at least in theory, we could have thousands of applications here. So this wouldn't work if we have a very, very large system, or if we have a very large system, this doesn't work. Or another way would be that Team D talks to all other teams and tells them that they have to test their application because they made some major change. But this doesn't scale very well as too, because then we have, again, if we have hundreds of applications, then it would mean that hundreds of hours have to be wasted on manually testing this stuff. So if we go to automatic testing, Team D could somehow trigger the end-to-end tests of all the applications. And this is definitely a possibility that you can do, but it's not the most efficient way to do it, because the feedback loops are kind of long that way. So because then you have to trigger all the tests of all the applications, and somehow then you are also somehow coupled to all the applications of all the teams, because you have to know about all the applications that depend on your service. So it's also not the best way to do it, I think. And this is where contract testing comes in. So imagine here we have like a contract, let's call it repositories, or some contract store, let's call it store. Here we have a contract store, let's write it out. And all of the applications state that we expect to get. So if we trigger a request to the product service that looks like /API/products and then some query string, for example, then we expect to get a return with a certain structure, a certain data structure. And then the applications can put this contract in the contract store. So the shopping list application puts their contract in the contract store. The e-com app does the same, and also the shipping app. And all the applications put all their contracts with the product service in the contract store. Then the automated tests of the product service, the automated contract tests of the product service, can look in the contract store, fetch all the contracts, and run all the contracts in separate tests. And if all the contracts pass, then we know that whatever we changed in the product service is doesn't break anything unexpected. So this is the idea of contract testing, that we decouple some microservice or some service like the product service from all the applications that depend on this service by having some kind of contract store or something like this. And in my POC, I have a shopping list app and a product service for now. Very simple versions of those of the app and of the service. So let's take a closer look at the code. Let's open the terminal as well. And what you can see here in the file directory, in the file tree, is basically a monorepo. So here we have contracts. This is this contract store I showed you in the graphic. And then we have packages. And we have a shopping list application package and a product service package. And in the contract store, what we do in the contract store is that we store all the contracts. And here you can see we have a contract for the product service. And in here we load the contracts from the shopping list application, and we will take a look at the contracts soon. But first, here we can see we export all the contracts. In this case, it's only one. But if we would have multiple applications, then we probably we would have the product service ecom, for example, for the ecom application and so on, and then we would spread all the contracts in here as well. So in the contract store, then we would have all the contracts with the product service of all applications. But for now, for this POC, it's only one application. So let's take a closer look at the contract itself. So let's go into the contract. Now we are in the shopping list package in the contracts file, and here we have one contract so far, the product service contract with a name. So this name, here we can choose any name. It's important for later. If the test fails, then this name should be descriptive, so we know where to look for problems with the failing test. And for the source, we pass the name of the application. Again, it's for later if the test fails, to know where to look for or which test fails. And then here we have a precondition, and this is where it gets interesting, because this precondition now serves two purposes. So we can use this precondition first for the tests of the shopping list application itself, but we also use this precondition as the definition of the contract data, basically. So I think I show you the test first. So if we go in the product list specification file, then we see here that the first thing we run is this precondition in the test. So the test states that it should render a list of products. So it's a very basic test, which simply makes sure that the products we fetch from an API endpoint, or from the product service in this case, are rendered correctly in the application. So we first run the precondition, which is basically setting up all the mocks, so we don't really make a network request. Then we render the application, and inside the application, we can see that we make a fetch request to some URI. This is the URI of the product service, or should be the URI of the product service on our local system. Then we render a list of the product names. And this is exactly what we are testing here. So we expect the very descriptive name of A to be rendered and also B to be rendered. Maybe I should have chosen better names. So let's go in that precondition. And inside the precondition, when running the tests for our shopping list application, we mock the API endpoint with mock service worker. So mock service worker is a tool for mocking fetch requests and other requests for testing. So in the has products precondition, we say whenever a GET request is made to this endpoint, instead of calling the endpoint and fetching the data from the endpoint, simply return whatever we specify in here. And in here we say we want to return a body with a product A and a product B. So this is the precondition when we use it in our shopping list application. So when we go back to the drawing here, the shopping list application, we write team A writes a test for the shopping list application. And the test is this one. And to make sure that we don't make a real API request to the product service for testing, we want to mock the API request, and we use a precondition for this. And in the precondition, we use mock service worker, and mock service worker makes sure that we respond to a fetch request with certain test data, and then we can check if the correct products are rendered. So we started in the contract, and in the contract we saw specification of the contract object with the precondition, which is the has products precondition, which we already saw, and we saw that we can use the has products precondition for testing the application itself. But now let's see how we can use this contract for testing the contract between the shopping list application and the product service without the product service relying on the shopping list application. So you can imagine the has products precondition in this contract as specifying what data structure we expect when making a request. So here we state when making a request to this endpoint, we expect to get a return that looks like this. Okay, so now when we go from the shopping list application to our product service, then we see here a contract specification file. So if we open the specification file, then we have some boilerplate code here basically, and at the end we run all the contract tests. And for now in this POC it's only a single one, and we do this by loading the relevant contracts from the contract store. So this is what we see in this folder on the root level. We have this contracts directory with the service product file, which exports all the contracts that are relevant for the product service. And then at the end, in a for loop, we iterate over all the contracts and then check the contract precondition with a custom get function. So if you remember in our precondition, where was it again? In our product precondition, we can see here we can override the get function. When running the application tests, we use the default value, which is this get function here, which basically uses the mock service worker library to mock API requests. But in our contract test, we use a custom get function instead, which is specified here. So this get function calls a seeder function and then runs an expectation. So in the expectation, we run a get products function from the product repository. We will take a look at it in the next step. and expect what it returns to equal the shape of whatever is specified in the contract. So I guess this sounds kind of complicated, but I hope I can clear things up a little bit. So here we can see that we pass the get function, and the precondition runs the get function and passes in the path and the body and maybe also headers, but forget about headers for now. The important thing is the body for now, and the body in the case of our product precondition is an array with products. So we map over all the products when we get the product, and we merge it with the general product shape, so to make sure that if we omit some data that's not needed in our shopping list application, that it's still inside that we still compare, or that we ignore all the data that is not necessarily needed by the product. So for example, in this product shape, we define that a product also has a description. But for now, our shopping list application doesn't care about the description. So in our precondition, we didn't specify a description, because for the shopping list application, it doesn't matter. Maybe for the ecom app or for the shipping app, the description is important, but not for the shopping list app. So by merging the product with the product shape, we can specify that any value for description is fine. So it doesn't really matter for this contract, but maybe for other contract it does matter. And if it does matter for a different contract, then the description would be overwritten because we spread the shape before the actual product. So in the case of the product precondition we use for the shopping list app, we override only the name. So in the shape we also see the name, but the name is overwritten because it's contained inside the product object here. But the description is not in the specification of the precondition of the shopping list app. So we take the description from the shape, and here we specify that we expect anything. It doesn't matter for this contract. So if whatever get products returns equals whatever we expect in the precondition, considering the shape, then this contract test passes, and if it's not the case, the contract test fails. Now let's come to the seeder part. So get products, if we go to get products, this file is contained in the service product repository file. So in a real world application, here we would query some database or maybe some third-party API or something like that to fetch the products. In this case, we pass a fake or in-memory database, and when we say create product, we insert a product, and when we run get products, we return all the products that are in this in-memory database. But in order to return products, we first have to seed the in-memory database with actual products. And we do this with the seeder function. And the seeder function gets the path. For now, this is not really important, but it would be, or we could use those information for a certain, for certain kind of logic we need to seed the correct table and stuff like that. And then we pass the method, which also don't care right now because it's only a POC, and here I didn't need it. The only important thing again is the body. So the data we specify in the precondition. First thing we do in the seeder function is to reset the database. So between contract tests, we always want to start from scratch. We always want to start with a fresh database. So we reset it at the beginning, and then we iterate over all the products, over all the products we specified in the precondition. So in this case, over this one and that one. And then we create a new product. This time we again merge some default data because, as I already told you, in this precondition we don't care about the description, but the description might be a mandatory field only because the shopping list application doesn't care about the description. Doesn't mean that maybe those two depend on the description. So maybe the create product method has a method to make sure that there is a description, otherwise we can't create the product. So that's why we need to spread some default data in here, and here we have the name and the description. And because in the product we only have specified the name gets overwritten with whatever we have specified in our precondition, but we take the description from the default product so that we can successfully create a new product. So this is what the seeder is for. The seeder in a real world application would probably seed a database. In our example, it only seeds a in-memory fake database. That's very simple. So our fake database has a products array, has an insert command where we can insert, or where we can append products to this products array, and we can reset the products. So simply overriding the array with an empty array. So now we can run the test in here. In our service product package, we can say npx ytest or vtest run. And we have two tests. First of all, we have a test for our product repository, which we didn't look at yet, but we also have this contract specification, which is the file we have open here on the left, and it says it passes. So everything works. The contract between the shopping list application and the product service works as expected. So let's check out what would happen if it doesn't work as expected. So let's go to the precondition, and in here let's make this name X and name X. And I guess now it should fail, yeah. Because now we're basically our shopping list application now says for the shopping list application to work, we need some property called nameX. And obviously there is no nameX property. So now the contract test in the product service tells us that something is wrong. Some contract isn't fulfilled. And in here we can see which contract isn't fulfilled. In here now we can see the app shopping list contract has products, for the has products precondition isn't fulfilled because we expected a nameX property, but we only got a description and a name property. So in this case, now we know either we have to talk to the, so if imagine we are in team D, responsible for the product service, and we see our test fails, like it does here. We now know we need to talk to the shopping list team. So somewhere we see, oh, the shopping list team is the team A. Now we need to talk to the team A and say, your contract doesn't work anymore because we need to make this breaking change, or we see that we breach some contract and we decide to not do this breaking change and work in some backwards compatible manner. Those are the two options. Okay, so far about the contract testing POC we have here. Let's change this back to name. And see if it runs again. Yeah, it runs. So what I want to do now is to make this a little bit more production ready. So for now it's very much a POC. but I want it to resemble something that actually would work in a real world scenario. So I think where I want to start is the product service, which we have seen only communicates or only works with in-memory database for now and doesn't really work for a real-world use case. So let's, for example, I don't have a selected. Open the application. I hope this works. I didn't try this out. Seems not to work. Let's check this. Okay, yeah, I guess actually does what I wanted to show you here. We're making a fetch request to the products endpoint, but this doesn't work because there is no endpoint, or there is no server running at this address. And I think that's the first thing I want to change, to actually make our product service work for real. So that we start a real server which returns real products. I'll probably do it with an in-memory database still, because I don't want to set up a database here now, but this should be fine. The important thing is I want to start a real server. Okay, I think I want to use Fastify for this. Let's see. Let's see how we can start this. Not some example. Reference documentation. Guides. Getting started. Yeah. That looks good. So let's install the package. Copy this one. Okay. Somehow my VS Code is complaining, but doesn't say about what, but okay. Doesn't really matter, I hope. Now we have Fastify running. Okay, and we need to declare routes and listen. Do you prefer to use async await? Of course. Let's see, let's do it like this. Get resource set. Oh man. We said API product. Check. Products, yes. Okay, and in here we can now use the get products. Need to provide the key, and is it async? No. So we can use, it's not very pretty, but we can use the test database async. Oh no. Let's copy this one. Let's do it like this for now. This is good enough. So now we have We have an endpoint, and we use our product repository with a fake or a very simple in-memory database. Okay, then we listen to port 3000. Okay, let's check this out. Product. We should start it as well, I guess. Node server. Here we're in the app. Go here. Okay, type module. Like this. Let's hope this works. Otherwise, we didn't install it in the wrong project, I guess. Yeah. We move it from the application, so we installed it in the application, but we need it in the service. Okay. Check again. Another error. Doesn't start great. Cannot find module repository. Okay. Why not? Determine back. No. Not quite sure what's the problem here. Let's try using CommonJS. I see. Let's revert this. Let's see. Okay. Obviously, we can't mix it. So let's revert it again. And see why this doesn't work. Maybe we need the ending, and maybe we need to use MJS. Probably. Not quite sure about the works. Fine. Okay, let's see. Okay, it returns an empty array, which is as expected because it's empty. So let's put in some fake data here. Name, who, description, var. Still doesn't work. Okay, we have to restart. I'm so used to not having to do this because Vite does it for me. Okay, now this works, and now let's change our application to fetch data from the real API. So we have to change the endpoint, put in the port here. Doesn't work. Course missing. Nice. So I think the easiest way to do this is in our Vite config. Proxy somehow. How does this work? Vite proxy API. proxy. Yeah, it's under the server. Okay. Server proxy. We don't have defined config, so we don't get type hints, which is annoying. So proxy is an object again, and here we can see API products. We proxy it to, yeah, we can reject this. We proxy it to that. And here we say API products like this. And like that, let's see. Products looks good. Okay, I think probably we have to specify JSON. Let's see. Let's Google this first. If I return JSON response. Let's do it like this. It's good. Don't have a lot of experience with Fastify, unfortunately. Let's see. This looks still good. Maybe we have to restart tweet. Is this possible? No. Not quite sure why we don't get the correct response here. Let's see if I have some mistake in the read config. So here we specified here we need this one to start. Let's check the documentation again. Yeah, probably is the problem. Let's see. It works now. Yep. Now it almost works. Looks like, oh, now we get the 404. API products not found. Restart real quick. Make sure that's not the problem. No. Why do we have products 2 times? Let's check the code in app. So this request looks okay, but somehow okay, this is automatically appended to that. I see. Kinda strange, but okay. Let's remove this one. Okay, now it works finally. So now we query the real API endpoint, and our application works. So we have a real server, and this part is basically like in a very simple production app. Now, let's see, I think our test now fails for this one because the URL of our fetch request changed. So in our precondition, we need to change it as well and specify it like this. Okay. Still doesn't work. Okay. Because this is somewhat complicated error, because when running tests in Node, fetch needs an absolute URL, because in a browser we know the current URL, but in Node we don't know the current URL, so a relative URL like this doesn't make any sense in Node. That's why we have to specify the absolute, the full URL, or the absolute URL. So this one is localhost, and whatever the port of our application is, like this. And then we also, maybe the test already works, but probably not. No, we also have to change it in pipe. So also here we add a full URL. Like I said, in the browser it really doesn't matter, because basically it bends whatever we pointed to here to the current URL, but in Node where we run our tests, this makes no sense because there is no current URL. So the app should still work when we start the dev server, but first run the test. Test works now again. Oh. And the application itself still works also. Okay. So what did we achieve here? Our product service now basically works like a real service would. Of course, it's very, very simple. We have only this in-memory database and stuff like that, but we could somewhat easily replace this database with a real-world database, and then replace the code in get products with some SQL query, for example, or whatever database we choose here. Okay, but now something is untested. What's untested now is this server here. So we basically don't have any integration tests for the server itself, and this is what I want to change. So we have a test for the product repository, which is fine. Here we use a in-memory database to test if the product service works as expected. This is fine. But now we also want to have integration tests which make sure that really the server works as expected. And I want to do this by making the contract test actually querying the server and not using the repository directly. So I want to use the endpoint itself instead of the repository. So this makes this test a little slower, but then we also have an integration test basically for free. So with the contract test, we get all our integration tests for free, which is a very nice side effect, I think, of this approach. But to make this work, we need to extend the functionality of our server. So we not only need the get endpoint, but we also need the post endpoint to create a new product. So post products. And in here, let's Google again how Fastify actually works with post requests. Post, okay. To have an example with the data actually. So post, okay. The request body makes sense. Let's see, post API products, request. And in here, simply send a success true, but we run create product. And create product takes the product into the database. And we get the product from the request body. Not quite sure if we have to pass it or something like that, what format it is. So let's console log the request body. See what it's about. And then here we need the in-memory database. Okay. So now we have an endpoint for creating products as well. Let's see in our contract spec. Let's comment out the DB. We don't want to rely on the in-memory DB for this. Let's comment out this one as well. So those are okay. And in the seeder, run create product, but in here we now want to run await. Let's make this async. Batch. First API product. Now we need some options. Method gets uppercase is post. Is it body? Yeah, it's body, and we have to JSON stringify the body, and in here we send those data. Okay. And we need a reset logic as well, but a problem for later access. So query the important post with a body. Let's run this and see what the server console logs. If we run this in here, let's go in the other package, in the product service package, and run npx test run. So you might wonder why they pass. The reason why the tests pass is because we removed the expect statement here. So we don't expect anything and we don't get anything. So what we expect is actually correct. Okay. Did we get a console log here? Let's see again. Where do we console log in here? You have to restart. It doesn't reload automatically. Run again. Okay. We didn't get any console log, only the debug output. So I'm not quite sure if we got here, actually. But we don't get an error here neither. I'm not quite sure what's this about. Do we need to specify more? Let's see. Post, method post. Maybe we need the headers. But other than that, it looks fine, I think. Let's do it that way. Try it again. There's no request here. Okay, why not? Let's put it to console log in here as well. Add more console logs. I think we can add it around this one. Maybe this will be useful. Okay, and run again. Something isn't working here, I think. Probably it's swallowing some error. Because we don't await the promises. Do we need to make this async as well? Yeah, let's do it. Like that. Now I await the precondition with the get to get this async. Yep. So I hope now we should get more output. Yep, we do. Okay. Not found. So there is some problem with our URL products. Yeah. Okay. That was a typo. Now let's see. Now we get an OK. This looks fine. I guess this looks good. And in here, okay, we logged data. Looks good. Looks good. Go back to the server. Now let's console log the DB products. Products in the database, like that. Restart the server and the test again. And now, okay, now we have in our database foobar and A and B. So A and B we seed. So this works, seeding works, and this comes from here. So we can remove the default data, start again. Okay, and now that our seeding works, let's remove the console log. A little bit annoying. Let's remove the create product, the old create product via the the repository directly. Now that the seeder works, we can replace this one here. This already is async, so in here we say await batch. This one, in this case, it's a GET request. So the only thing we need to do here is to say then response.json like this. Okay, so now let's check our test, and it passes. And the nice thing now, our test basically is our contracts test basically also serve as integration tests, because we fetch the data via the real endpoint. So not only do we test our application logic, but also our server logic here. So we test both the get endpoint and also the post endpoint. Maybe it's not a complete replacement for all your integration tests, but thinking about it, I think it should be a complete replacement of all your integration tests, because if all your applications provide contracts, so like all the applications that depend on your service add their contracts to the contract store, then basically all the features your service provides should be tested via those contracts. And if some feature of your service is not tested via contract, then it means that the feature is dead. It's not used by anyone. So in a perfect world, really all the data those applications need from your service is specified in the contract store via their contracts. And so all the features your service has are tested with the contract tests as well. So I think that's pretty neat. Okay. Good. So far I'm happy with the results. I guess if we run the tests again, do they fail? Maybe they fail when we run them a second time. Yeah, they fail because we don't reset the database. So now if we start fresh, then they should succeed again, and if we run them again, then they fail. So yeah, I'm not in the mood of fixing this yet, but it's because we don't reset in the database. So every time we run the tests, there are more data in the database, and then the expectation here doesn't work. So we need some endpoint to clear the database basically, or restart maybe the best solution would be to restart the server every time we run a test. Not quite sure about it. Okay, that's that. So I think that's a pretty good place to wrap today's stream up by walking through the contract testing concept again. So to see what this approach accomplishes and how we accomplish it in this very, very simple proof of concept system. So the basic idea, again, to repeat what I said at the beginning, but I think a couple of people joined only now, so I think it's probably interesting to a few of you. So the basic idea of contract testing is that we have a large system. In this case, it's a small system, but imagine it to be a large system with a lot of applications and a lot of teams maintaining those applications and a lot of services which those applications depend on. And those services are also, again, maintained by separate teams. So in this very simple example, we only have 3 applications. Imagine we have 3 applications, all depending on the product service, microservice, for example, so some HTTP service or some GraphQL service, whatever. And this product service is maintained by team D, and those applications are maintained by team A, B, C. So all those teams want to work independently. So team D wants to make changes to their product service without communicating extensively with all the teams that rely on their product service, because those might be hundreds of teams. So there might be hundreds of applications which all rely on the product service. So team D doesn't want to or isn't able to communicate with all the teams relying on the service. So we need a way how team D can make sure that whenever they make a change, this change doesn't unexpectedly affect any of the applications that rely on their service. And we can do this by specifying contracts. So the shopping list application says we need, whenever we fetch the endpoint, the API products endpoint, or let's go to precondition. Whenever we fetch the API products endpoint, then we expect to receive an array of products with at least their names to it. So the shopping list application specifies this contract and puts it in the contract store. The ecom application maybe has a similar contract, or it has other contracts where it specifies whenever we query a list of products, we also need the description. So we need a name and a description in here. So when we fetch this endpoint, we require an array of products with name and description, for example. And the shipping app says when we post to the API products endpoint, then we expect that a new product is added to the database. And all those teams or all those applications store the contract in the contract store. And whenever team D makes a change to their product service, they run their contract tests, and the contract tests look into the contract store, get all the contracts from the contract store, and then iterate over all the contracts, like we do it here. So we iterate over all the contracts regarding our product service, and then run the precondition with our own get function. And the get function seeders the database with the data we expect to be returned, and then runs an actual fetch request against our application. So we fetch, so we have a real integration test / contract test. So we fetch the data from our endpoint, and then we check if the data equals whatever is specified in the contract. So here we check if the data received from our API endpoint matches what the shopping list application has specified in their precondition / in their contract. And by doing so, we can make sure that team D can make changes to the service while being confident that they don't break any of their consumers, because the consumers need to specify all the relevant interactions or all the relevant dependencies to the product service in contracts. And so team D can assume, as long as all the contracts are fulfilled, that the product service is ready to be released without testing the product service with all the applications that rely on it. So if we don't have contract tests or some form of testing, then we need to somehow make sure that we didn't break any of the consumers. We can say, we specified some API and we just rely on all the teams adhering to this API, but maybe you break something which you didn't expect to break, or maybe you change some private API which you are not aware that those applications are still using, or some deprecated API, for example. So there are a lot of reasons that something can go wrong. as I think all of you have experience with this. But with contract testing, we can make sure that we are confident that whatever change we made to our product service doesn't break any other application. All the while, we don't need to know which applications even rely on our product service. So it doesn't really matter if there are hundreds of applications all relying on our product service, or if there is only one. We don't really care about all the other applications. And if one of the contract tests fails, we either have to contact the team. For example, a contract test for the shopping list application breaks. Then Team D can communicate with Team A that there will be a breaking change and they need to fix the application to make sure the application works with the new API. And then when they have done this, they can run the contract tests again. And if the contract tests succeed, then they can publish the application. Or if the contract test fails, for a reason Team D didn't expect it to fail, then they can revert the change and make sure that it's backwards compatible, for example. So I think for large-scale systems, so not for systems of this scale, but for systems with hundreds of applications or at least dozens of applications and maybe like a dozen and also dozens of services, it makes a lot of sense to implement some form of contract testing. So either you can build your own system as we did in our POC, or you can take a look at something like Pact, which I didn't have a lot of success with, but it highly depends on your stack. So my problem was that we are using PHP and it didn't really work very well with PHP. But yeah, if you want to have a ready-made solution, you can take a look at Pact. And otherwise, you can come up with your own solution like we did in the POC. So I think that's it for today. I hope you learned something and you enjoyed the stream. And I hope as well that I can stream more regularly. So now the plan is to stream every Sunday around this time. Let's see if this works out. If you have any suggestions for topics, you can tweet at me on Twitter at Oberliner. And yeah, I think that's it. So have a nice evening or whatever time it is in your time zone. See you.